Before we do some exercise, I would like to recall 2 pages that we learned about from the earlier discussion on the design. So recall number 1, let's now recall the architecture for the design number 3 with the inheritance. Right, so you can see the 2 arrows over here simply represent the extends keyword in Java. So this is parent class students, and we got 2 subclasses or 2 child classes, resident students and non-resident students. Let me just highlight the attributes that and also methods you should really pay attention to. So we got the string name, and also courses array, and also the integer counter. All these 3 attributes will be common to both the resident students and also non-resident students. They will all be inherited to the 2 subclasses, right? And also we got the constructor, including its implementation. We got the register method, and also we got the get tuition accessor method as well. Mutator and accessor, all of them will be inherited to the subclasses. However, in the subclasses, you may also choose to do several things. Number 1, you may actually choose to declare new attributes. You may choose to declare, for example, in the resident students class, the premium rates. In the non-resident students class, the discount rate. And also, you may also decide to have the new method, like a set premium rates in the resident students class, or set discount rate in the non-resident students class. And you may also choose to actually reuse the method from your parents using the super keyword. You may also choose to overwrite the methods, for example, get tuition over here, that you actually inherit from your parents. So this is the one I want to explicitly point it out again for you. You can think about here, this one over here is overridden. And the same method is also overridden in this subclass over here as well. The reason that it is overridden is because you can see, for example, in this get tuition here, not only that you are calling the version that's from the parents, you're also defining some extra line of code. Of course, in general, you can define as many extra lines of code as you wish. And here you can see we also override this inherited method by calling the parents version using super, and also we are writing some extra lines of code. Right, so that's why we have 2 instances of the overriding for the methods. All right, so that's about the architecture for the code, which we went over already in detail. Let me recall number 2. Let's recall another, just to compare, to really compare several things together. So that's the architecture diagram I just spoke about in the previous video, right? That one is just about students, resident students, and non-resident students. And we simply summarize about the common things that will be declared in the student class. All of them will be inherited to the 2 subclasses, right? And also we'll talk about the overridden version for the get tuition, which I also spoke about here, right? And we got these 3 decorations. We got Stella, we got Rachel, we got Nancy. So they are all declared to be some kind of students. So that's something I want to also mention here, just a little more explicitly. As we said before, whenever you're trying to declare some variable, for example, over here, you got variable s, variable rs, variable nrs. Okay, we got 3 variables. What's their declared types? Their declared types simply appear to their left. We got students over here, we got resident students, and also we got non-resident students. All these types are so-called static types. And what's so important about static types? I'm going to write it down over here. Okay, so all these types are declared types. However, when we talk about reference variables, right, you can see S, RS, and NRS. They're supposed to store references of objects. So that's why we say they are reference variables. But they're more like a static type, meaning that once they are declared, they will never be changed. That's something I'll speak about later. Okay, and what's so important about static types? Static types determines what attributes or methods, and also methods are available for use in the class. For example, if you look at the first one, let's say students, what attributes and methods are available in the student class? Well, in this case, definitely constructor, register, get tuition, name, courses, and also NOC, right? The counter. That's about the available attributes and methods for use. What about, let's say, resident students over here? For resident students, number one, it will definitely inherit everything from the parents, meaning that all the constructor, register, get tuition, name, courses, and counter, right? In addition, we also got the premium rates, we got a new constructor, and also we got a set premium rates, and also we got an overridden version of the get tuition. So you can think about the get tuition over here and the get tuition over here. We're talking about the same method. It's just that in this level over here, we have overridden that to a specialized version, applying the premium rates. Similarly, what about the available attributes and methods for non-resident students? In that case, again, we're going to get all the attributes and methods and constructor from the parent class. And we also got some additional ones that's declared in that particular class. For example, the constructor for non-resident students, discount rates, set discount rates, and also we got an overridden version of the get tuition. So this version over here is simply an overridden version of the get tuition over here. All right, that's about what I meant by available attributes and methods that are actually available for use in the class. And this phrase over here is really can be summarized in a single word, can be abbreviated. That's so-called expectation for the class. Okay, so attributes, methods available for use in a single class is called its expectation. So in summary, what I'm really trying to express over here is once you declare the type of a particular reference variable, it determines the static type over here determines the expectation of that particular variable, meaning what kind of attributes and methods you may invoke on that particular reference variable. Apparently, the expectation for students would be different from the expectation for resident students, and also would be different from the expectation for non-resident students. For example, conceptually, the expectation for resident student will be bigger or wider than students, because not only that every expectation of students, like over here, they are inherited to the resident students, so they are all supported. In addition to it, the resident student also support these things over here. So that's why I said the expectation for a subclass is actually bigger. What about between siblings? Their expectation will share something in common. In this case, whatever expectation is on their common parents, that will be shared. That will be the shared expectation between the sibling classes. However, the sibling classes might have different expectation. For example, for resident students, the expectation about premium rates and set premium rates is not shared by the non-resident students, where we got discount rates and also set discount rate, and vice versa. All right, so that's something very important to tell you. So this note about this term expectation very well, because we're gonna do some exercise based on that expectation. And you can also see the expectation somehow get reflected in the object structure, which we also visualized in the earlier part of the module. You can see, for example, students, the parent objects, resident students, and non-resident students, right? So let me just highlight again. Over here, you can see this part over here is really the part of the attributes that will be shared, that will be inherited to both subclasses over here and also over here, right? You can see that will be inherited. You can think about conceptually, this is inherited to both subclass objects, inherited. On the other hand, you can see this part over here about the premium rates for one subclass is different from the discount rate from another subclass. So these are the subclass specific attributes. Okay, let me just write it down. So that'll be subclass specific attributes. Okay, so let's now do one exercise together. Okay, the exercise is, let me just present to you on the slides. Okay, now considering this architecture that we just recall, now I would like you to consider again these three reference variable declarations with the 3 static types, which will determine the reference variables expectations, right? Now, I have this table over here. Each of the columns is simply the attributes that are declared either in the student class or the resident student class or the non-resident student class. I just enumerate all of them. Okay, so we got the name, attributes, registered courses, like a courses over here, number of courses, the counter, and also the registration. That's the register method, which is over here, and also get tuition over here, and also we got premium rates, set premium rates, discount rates, and also set discount rate. What we want to know is, for example, oh, actually, that's already the answer. Pretend you didn't see that, okay? Help me out. Okay, so here, let's say if you put some the reference variable either s or rs or nrs over here as the context objects, what can be expected by means in terms of making a method call or attribute call, right? For example, if I got s, can I say s.name? Can I say s.courses? Can I say s.noc? Can I say s.pr? And etc. Right? I want you to consider the same entries for also rs dot and also nrs dot. That's the exercise I want you to do. Okay, let's now switch to my iPad. Please forget about the answer you just saw, which I accidentally showed. Okay, let's now take a look at it. Okay, the hierarchy over here, the inheritance hierarchy, and also we got the 3 reference variables, right? Let me just say again, over here, it is so important for you to realize students, resident students, and also non-resident students here, they determine the expectation. So these are the static types. Static types, which determining expectations. Okay, let me highlight it. And as for what expectation really mean, you can see from this page over here, right? I already defined that in the earlier page. Okay, now how do you fill in this table over here? Okay, you can pause the video and think about it, and then we'll go over the answer together. All right, assuming that you thought about it, okay, let's now try to answer that in a more systematic way that's consistent with our remarks so far. Let's think about these attributes over here. Let me put it here. What about these attributes? The name, register courses, number of courses, counter, register, get tuition. So these are all the attributes or methods that are actually declared in the parent class, right? You can see all of them exactly over here. 4, 5, and 6, all of them. Okay, let's now, the only one that's not included is the constructor, right? Let me just erase it. Okay, let's not confuse you. So we got 5 of them over here. So all of them will be available, will be expected on not only the student type, but also they will be inherited to resident students and also non-resident students. Also, all of them should be able to say, for example, s.register or rs.register or nrs.register, because they're all inherited to the subclasses as well. So that's why I'm going to say over here, so let me say Y for yes and N for no. So definitely for this part here, name, register courses, NOC, register, get tuition is going to be yes. Meaning that you can say s dot name. You can also say rs dot name. You can also say nrs dot name. So that'll be yes and yes. It's going to be yes for all these common attributes and methods. They will be supported on both the parent class and also subclasses. Okay, so far so good. This part should be easy. So what about other attributes that seem to be subclass specific, right? Let's now take a look at one of them. For example, you can see PR, premium rate, and set premium rates. They seem to be specific to premium rates over here and also set premium rates. So they should be available only for resident students class, but not the other two. So these 2 attributes are the newly defined attributes, so they don't belong to the student class. They are not inherited. They are simply like a child-specific attributes that are not shared by the parents or they are not shared by the sibling, right? So that means the only class that can be expected for premium rates and set premium rates will be resident students variable. In that case, it would be here. It would be the resident students over here, the static type. So the only variable that has this subclass type is RS. So that means RS over here, right? So that means we're going to say yes for RS. Yes and yes. On the other hand, for the other two, it's going to be no and no. All right, symmetrically, what about the other one? The other one is, what about discount rates and set discount rates? So these two attributes and methods belong to, you can see discount rates and also set discount rate. They belong to the non-resident students class, meaning that, so these are the newly defined or newly declared attributes and methods. They are not shared by either the parent class or the sibling class. They only belong to this particular subclass, the child class. Okay, so the way to fill it in is to say the only one that's going to have it support them will be over here, NRS. And the only variable that's of type NRS, like a non-resident student, will be NRS over here. Okay, so we should say NRS discount rate should be okay. NRS set discount rate should also be okay, right? That should be compilable. Okay, so let me just make a note quickly. So whenever I say yes over here, so what I meant was it will compile. Java compiler on the Eclipse is going to compile that code. On the other hand, for N, that stands for no, what I meant was it's going to fail to compile. You can definitely try this on the Eclipse, but I would say I would really expect that you will be able to judge this just by examining the hierarchy for the classes and also the static type of the variable. That should be enough for you to judge. You don't really need to rely on the compiler to do it for you. Okay. Okay, let's complete the table. And then for S and RS, their static types are simply students and resident students, which do not share these two subclass specific attribute for non-resident students. So we're gonna put no, 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 and no. All right, so that's about the exercise. And let me recap very quickly. For this part of the module, you want to make sure you understand based on the static types of a particular reference variable is going to give that particular variable different expectation. Expectation simply means any attributes or method that will be available for use by using the dot notation. You might say s dot something or rs dot something or nrs dot something. More precisely, this is the table that will define the complete expectation for the three static types over here, right? How do we determine the expectation? You want to look at the complete declarations on each of the classes to really determine. Okay, all right, that's about it. And in the next video, we will talk about some intuition of the most important two concepts, namely polymorphism and dynamic binding.